All right, so I hope today is going well. I'm sorry I had meetings today, but at this point, you should have worked with your group to complete all of the following questions. So maybe there were some ones you were confused on. I really hope you asked the people near you. Now that you've attempted everything you can, go ahead and listen through. Especially if there's ones you're confused on, you can listen to the explanation of how you solve it. If you're more so just looking for the answer, then just skip ahead to see if you got it. Remember that you are going to put in smileys or corrections because the sub will be collecting these for me to check your progress and how far you got in class. So for these, we're asking to evaluate. Evaluate means a single number for our solution. So let's rewrite this as an exponential. So our base is 3, our exponent is unknown, and our answer is 27. So 3 to what power is 27? Well, 3 times 3 is 9. 9 times 3 is 27. So your solution is x equals 3. And then we're going to repeat that process. 5 to the power of some unknown value equals 1 over 125. So right away in my head, I'm thinking, okay, we went from a whole number to a fraction, so it got reciprocated. So we know that our exponent will be negative. Then I ask myself, 5 to what power is 125? Well, 5 to the third power, so our exponent is negative 3. And then just repeating that process again and again. So 25 to the x power equals 5. So there's two different ways to think about it. You can know that 25 is bigger than 5, so we're taking some sort of root. Well, I know that the square root of 25 is 5, so x will have to equal 1/2. If you're Miss Maga, I don't know how you got that. Well, let's rewrite it where they both have a common base. Well, we could get a base of 5 for each. So 5 to the second power is 25. And there was an x up there, so we include the x. Equals 5 to the first power is 5. Now that you have common bases, you can set your exponents equal. You get 2x equals 1, divide by 2, and you get the same solution as you did there. All right. We know that the base of natural log is e. So we can say e to the x equals e to the 9th, or you just know that natural log of e, they're inverses, and that'll be equal to 1. So therefore, our solution is x equals 9. All right, our last two, same process. 7 to the what power equals 1. Well, anything to the 0 power gives us 1. So whenever you have an argument of 1, your solution will be 0. 8 to the x power equals negative 8. If I said negative 1, that wouldn't work because that would be 1/8. So you can't have a negative argument. Therefore, this is undefined. So smiley face if you got it right, corrections if you got any wrong. All right, so remember our equations. Our first one's our basic one. This one is with compounded. And this equation is with continuously. Don't just memorize the order because remember, order can always change. A 4-foot tree is planted, so originally planted, and will grow at an annual continuous growth rate. So that tells us we're going to be using our continuously equation. If in 7 years, the tree will be triple the original height, what is the annual growth rate? So because of continuous, we're going to be using our PERT equation. So off to the side, we'll list out our key variables. I notice a lot of the times we like to write this out. So we know that P, our starting height of the tree, is 4. We know that our time is looking at in 7 years. It wants to be triple the original height, so 3 times the original height, which is 12, and it's asking us to solve for the growth rate. In your PERT equation, there isn't an n, so we don't need anything there. So go ahead and erase it or cross it off. So now let's substitute our values in. Okay, our goal is to always get our exponential by itself. So what value has an exponent? The e. So we need to get the e by itself. So since the 4 is being multiplied with it, we need to divide both sides by 4. And we get 3 equals e to the 7 times r. Now, if your unknown is in the exponent, that means that you're going to have to use a logarithm to solve. So what's the inverse of an exponential with a base of e? A natural log. So to both sides, we're going to do natural log line. Notice where I'm placing the line. Natural log line. Everything from that side comes down, so 3. Everything from the right side comes down, so e to the power of 7 times r. There's no e to the power on the left-hand side, so the natural log of 3 remains the same. However, here, we know that natural log of e are inverses and simplify to be 1, so you're left with 7 times r. R isn't by itself yet, so we got to divide both sides by 7. And our rate is natural log of 3 divided by 7. So we want to turn our rate to a percent, so let's go ahead and type this in our calculator to see what we get. So you're going to hit alpha y equals, enter, and you now have your fraction. Your natural log button, the ln, is right next to that 4. And it was natural log of 3, all divided by 7. So 0.1569. However, it wanted that rate to be in a percent. So rate to percent, you multiply by 100. So if I multiply this by 100, I get 15.69%, so we'll go ahead and round it up to be a 16% growth rate. All right, for this one, ask yourself, what type of function is it to start? Is it a logarithm or an exponential? Well, it has exponents, so it's an exponential. And we need to get a common base. So we need the base to be 3. So go ahead and rewrite with a common base. So 3 to the second power is 9, and 3 to the third power is 27. Don't forget about what was already in those exponents. And you're going to go ahead and distribute those. Now that you have one base and exponential on each side, what's the inverse of an exponential? A logarithm. And since the base was 3, with a base of 3. So you're going to do log base 3, line on each side. And every single thing, including that 3, is going to go there. And same on the right side. Log base 3 of 3 simplifies to be 1. And you're left with 2x plus 2 equals, on this side, log base 3 of 3 also simplifies out. And we can now go ahead and solve for x. So we don't see any x squared, so we can just move our x's to one side and our constants to the other. And we get x equals -4. Remember, exponentials have a domain of -infinity to infinity, which is not restricted, so we don't have to check when it's an exponential to start with. All right. Now for this one, it wants us to solve for x, so our type of function, if you haven't noticed, is a logarithm with a base of, well, there's nothing there. If there's no base, it's a common base, which is 10. But logarithms, your argument has to be greater than 0. So if you look here, we have a vertical asymptote at 0 and -6. Well, which one's smaller? -6. So our solution has to be bigger than -6. Remember, we always check in the original. So now we can't solve a log until there's only 1 on each side. So on the left-hand side, there's only 1. That's awesome. But on the right side, there's 2 with a plus sign, which means we're going to multiply our arguments. So when we do that, we get log of x plus 6 equals log of x times x is x squared. Now, what's the inverse of a log? An exponential. And since the base was 3, we do the big 10 line equals big 10 line. And you're not just writing the x plus 6, you have to make sure to include the log. And that base of 10 here is assumed. So when the base of the log and the exponential match, they simplify out and you're left with the argument. And the same thing happens here. Now, this time we have an x squared, which means a quadratic. When you have a quadratic, you need to move everything to one side to get it set equal to 0 to factor. So I like to keep my x squared positive. So I'm going to subtract over the x, and it cannot combine with the x squared and the 6. So we get 0 equals x squared minus x minus 6. Now go ahead and factor this. What multiplies to be -6 and adds to be -1. So well, -3 and +2, let's check. Those add to be -1, so we have our factors. So 0 equals x plus 2 times x minus 3. You set your factors equal to 0 to solve for x. So we get x equals -2 and x equals 3. Since it's a logarithm, we know that logs have to have positive arguments, so bigger than 0 and not negative. So you need to check them separately in the very, very, very first one. So if I check -2, we have log of -2 plus 6 equals log of -2 plus log of -2. Automatically here, I see that we have negative arguments, which means caution. Even if I multiply them, it's checking in the original. Negative 2 is smaller. Well, if we look here, that domain should have been 0 to infinity, is smaller than 0. So negative 2 is an extraneous solution. Okay, let's go ahead and check 3. Here, all of my arguments are positive and greater than 0. So x equals 3 works. Again, smiley if you got it right, corrections if you got it wrong. Now we are going to do our last page of checking. So it's all about condensing. We know that when there is a plus, that means we are going to multiply our arguments. But I always first check, is there any numbers in front of the logs? No, that's good here, so we don't have to exponentiate anything. So we're going to go ahead and distribute. So x times 2 is 2x. Negative 1 times 2 is negative 2. That's our final condensed log. In B, none of them have numbers other than 1 in front. So when we have subtraction, that means we divide our arguments. And this one is always in the numerator. The second one is in the denominator. So we have log of 4x squared divided by 16x. Now let's check, is there things that we can divide? 4 and 16 can divide, and 16 is bigger than 4, so it'll be in the denominator. And x squared over x, well, you'll have 1x remaining in the numerator. When you have a number in front of the log, it becomes the exponent of that whole argument. Similar to here, okay, I see the plus sign, so we multiply, but first we have to deal with the numbers in front of those logs. So it'll become log base 4 of x to the 4th plus log base 4 of 2 to the 2nd. So let's simplify anything else we can. The 4 applies to everything in that argument, so log base 4 of x to the 4th plus log base 4 of 2 squared is 4. Now in order to condense those, there's a plus sign between them. We're going to multiply our arguments, so you're going to do x to the 4th times 4. And you have log base 4 of 4x to the 4th as our final solution. Smiley face if you got it, correction if you got it wrong. And our last one is standard 3a. So anytime something has a vertical asymptote like you see here, so our x is getting restricted, it is a logarithmic function. So we have a vertical asymptote at x equals 5. Domain is our span of x's, so we see nothing here, but our x's start from 5 and then go forever to the right to infinity. So our domain is 5 to infinity. But if we look in terms of y, they're spanning forever, so they're going to go from negative infinity to infinity. Taking a look at g of x, is it a log or an exponential? Well, it says the word log in it, so it's going to be a logarithmic function. Reminder again, logarithms have vertical asymptotes which affect x. So for your vertical asymptote, you set your argument equal to 0, and you have a vertical asymptote at x equals 1. domain is restricted, and we have a negative a value, so it'll look like this. Still, however, the span of our x's is from 1 to infinity, and our range, our y values aren't restricted, so from negative infinity to infinity. Exponential functions have horizontal asymptote. So if you notice here, your y values are getting restricted, so exponential. And we have a horizontal asymptote at y equals 3. Notice how it's y equals, and y affects your range. So our first y value is at 3, and then it goes on forever to infinity, so from 3 to infinity. Whereas in terms of x's, we had arrows going both ways, so our domain goes from negative infinity to infinity. So at this point, make sure you have all of your answers checked. If you got it correct, you'll put a smiley face. If you had to add or do corrections, go ahead and do so. Turn this into the sub, and then you are going to complete homework number 8 on Canvas. And